So today I'm going to discuss that using matrix representation we have to show that average position and average momentum of the particle in the oscillator are zero. So what is the meaning of average position? Average position means its expectation value. So let me start with the expectation value of the position. So this is the expectation of value of the position, and this can be written like this. Means it is basically expectation value of this. But if I recall, x in case of harmonic oscillator, can be written as h cross 2m omega cross 2m omega whole under the root a plus a dagger, right? So this is the value of this. So that means this x is can also be taken as proportional to a plus a dagger. So if I put this value here, so that means this equality is proportional to psi n a plus a dagger, psi n. So what does it mean? It means that it is psi n a. Yeah, let me write down it in the form of operator. So a psi n plus psi n means, if I elaborate this expression, then it can be elaborated like this. So let me recall another relationship, that a can be written as under the root n minus 1. It is for the harmonic oscillator. So a n, it can be written as, so that means now I am having a quantity psi n, so it can be written as n under the root n and psi n minus 1. So it can be written this way. Similarly, a dagger psi n can also be written as n plus 1 under the root, and it is psi n plus 1. So I have to use these two values here. So if I use it here, so then what I'm getting, yeah, so it is basically equal to, or rather than equal to, let me write down in terms of basically proportionality. So that means this is proportional to, this portion is proportional to psi n, uh, it is proportional to psi n minus 1. So that means this can be written as psi n minus 1. And similarly, this psi n and this portion is proportional to psi n plus 1. So that means it is psi n plus 1. This is the way. So that means if I use the properties of the wave functions, then they are separately equal to 0. So that means the result will be basically overall 0. So that means expectation value of position will become 0. Expectation value means its average value. Expectation value or average value, both are the same. Now let me go back to again the momentum. So if I talk about the momentum or the expectation value of the momentum, so what should I do to do that? Let me go to the momentum part. Uh, yeah, let me come back to the momentum part. So that means expectation value of momentum can again be written as like this. Uh, let momentum is equal to psi n p psi n. But as we know that this p is basically, for the harmonic oscillator, it is basically minus iota m omega h cross over 2 under the root into a minus a dagger. So that means momentum operator is proportional to a minus a dagger. So that means if I use this, I can write it down as it is psi n, it is a minus a dagger psi n. So it is psi n a dagger, sorry, a psi n minus, just it is psi n a dagger and the psi n. So what if I use these relations, this and this, then this is basically psi n and it is psi n minus 1. And similarly, so here rather than using equality, I am using the symbol proportional. So it is psi n and it is psi n plus 1. But these two terms are separately equal to 0. So that means overall this is equal to 0. So that means expectation value of momentum is also be 0 for the harmonic oscillator. So that's all for this numerical problem.